Welcome back to Basic Mathematics. In this video, we're going to be looking at expressions containing fractions. There are two big ideas that I want to get across in this video. The first one is that a mixed number is really an expression with some stuff going on in there. And when we have mixed numbers, we can still perform our operations, but sometimes it's a little bit tricky to see how it's going to work. The second idea is that the order of operations still applies when you have fractions, and you can have fractions that involve several operations going on at once. So without further ado, let me get my head out of the way, and let's start with the second of those ideas. Consider the expression 2/3 plus 3/5 all over 8. This is what's called a complex fraction. It is a fraction that has fractions in it, because you like fractions so much you want to work with fractions before you can work with fractions. Working through this is a lot easier than it looks at first glance. According to the order of operations, the numerator and denominator of a fraction should be considered separately, and only when you are down to number over number do you work any further. So we can look at just this thing going on in the numerator. 2/3 plus 3/5. And in fact, I do tend to take the numerator and bring it off to the side and work just on that before bringing it back to continue working. To add two fractions, we need a common denominator. 3 and 5 have nothing in common, so we're left with the brute force approach. Let's multiply this fraction, top and bottom, by 5. Let's multiply this fraction, top and bottom, by 3. Doing that gives me 19 over 15. Then I can take that result and bring it back into the original fraction and write down that I have 19 over 15 all over 8. You'll notice here that I wrote the fraction in the numerator using a slash notation, 19/15. That's to make it a little bit more clear how this fraction stacks up. If you wrote it straight up and down, 19 over 15 over 8, it's not clear if we have this result or that result, 19 over 15/8. I'll come back in a moment and show you why it's important to make that distinction. But I also want to mention that there are some problems in our textbook that involve situations like this. To make it clear what's going on, one of the fraction bars should be a little bit wider and a little bit thicker than the other ones. Sometimes it's a little bit hard to tell, but if you squint and you look closely, you should be able to tell that one fraction bar is bigger than the other one. And that's how you split things up. So this is the bigger fraction bar. The smaller fraction bar, I'm going to rewrite using the slash notation here so that I can go from there. Now, to finish this problem, fraction bars mean division. So 19 over 15 over 8 is 19 over 15 divided by 8. We can use the rules we know for dividing fractions. And write this as 19 over 15 times the reciprocal of 8, which is 1/8. If we could, we would reduce at this point, but there's nothing to reduce. So we multiply across. 19 times 1 is 19. 15 times 8, well, you may not know that one offhand, 8 times 5 is 40. 8 times 1 is 8, plus 4 is 12. So I get 19 over 120 as my result. Because I mentioned that there can be some confusion and it's important to notice where the fraction bar actually falls, I did want to take a look at 19 over 15 over 8 to compare with the result we just got. Once again, fraction bar means division, so this is 19 divided by 15 over 8, or 19 times 8 over 15. I can always take a whole number and write it over 1 so it looks like a fraction, and that allows me to multiply across. 19 times 8, again, probably you don't know it offhand. I'm running out of room, so I'm going to talk through a nice trick here. 19 is just 1 away from 20, and 8 times 20 is easy. It's 160. So 19 is 1 less, and the product will be 8 less because you add 8 for each thing, right? 8 times 19 is 8 added to itself 19 times. 8 times 20 is 8 added to itself 20 times. So if 8 times 20 is 160, take one of those 8s away, you get 152 as the result of 19 times 8. So 152 over 15, definitely very different from 19 over 120. And that's why it is so important to pay attention to your fraction bars and make sure you know where the main fraction bar is. The other thing I said I wanted to talk about was mixed numbers. Consider here the numbers 3 and 5/8 plus 5 and 7/8. The trick to working with mixed numbers is understanding that mixed numbers are hiding addition. It even says it right in the name, 3 and 5/8. The word and in the English language is very often used to hide addition. So 3 and 5/8 is the whole number 3 plus the fraction 5/8. 5 and 7/8 is the whole number 5 plus the fraction 7/8. And because this is all addition, we have the commutative and associative properties of addition. We can group together the whole parts, 3 plus 5. We can group together the fractional parts, 5/8 plus 7/8. 3 plus 5 is 8. 5 plus 7 is 12. So we get 12 over 8. And I'm going to go off to the side for a moment and just focus on that fraction, 12 over 8. A couple of things to notice here. First of all, this reduces. You can divide top and bottom by 4 to get 3 over 2. And that is important to look at first. The other thing I want to notice here is that this is an improper fraction. And while mixed numbers are fine and improper fractions are fine, a mixed number with an improper fraction in it is not okay. So we can't leave this as an improper fraction. We have to convert from an improper fraction to a mixed number and rewrite our expression as 8 plus 1.5. Now we can add the whole parts. 8 plus 1 is 9, and get 9.5 as our result. When you are looking at subtracting mixed numbers, you can use the same ideas to your advantage, although they look a little bit strange when they go in the other order. Consider here 3 1/7 minus 1 5/7. And this problem I've written in column notation to make it a little bit more clear that we're looking at 3 minus 1, which we could calculate no problem. And then we're looking at 1/7 minus 5/7. And that would be a negative number. And that actually is also a problem. You can't have a mixed number that has a negative fractional part. So we have to get a little bit creative in how we deal with this. The way we're going to get creative is we're going to take 3 1/7 and we're going to borrow some of the whole part. 3 1/7 is the same thing as 2 plus 1 1/7. And now we can subtract and everything will work out. 2 minus 1 is 1. 1 1/7 minus 5/7. Well, that's a little bit tricky, but we can take 1 1/7 and we can convert from a mixed number to an improper fraction. And then see that 8/7 minus 5/7 is 3/7. I'm going to go through another example like that because it's a little bit messy to see. Consider here 12 2/9 minus 5 8/9. Again, if you could subtract the fractional part, 2/9 minus 8/9, because 2 is smaller than 8, if we did that subtraction, we would end up with a negative number. And we don't want to end up with a negative number. So instead, we need to do something different. And that's why we borrow. So we borrow 1 from 12, which takes it down to 11. And then we get, instead of just the fraction, the mixed number, 1 2/9. And here we can actually do the subtraction. 9 times 1 is 9, plus 2 is 11. So 1 2/9 is the same thing as 11/9. And 11/9 minus 8/9 does give us a positive value, which is what we needed. 11 minus 8 is 3. Let's stay over here for a moment. We get 3/9, a fraction that reduces. I can divide by 3, top and bottom, to get 1/3 as my result. Then subtracting the whole parts, 11 minus 5 is 6. So 12 2/9 minus 5 8/9 is 6 1/3. All right. So with that, I'm going to wrap up our discussion here on fractions. Take a look at the practice problems related to this, and I'll see you in the next video.